Let's find the zeros of a third-degree polynomial. To do so, we're also going to go ahead and factor this third-degree polynomial without any heavy lifting really along the way. So first, let's go ahead and list out what are our possible rational zeros. So our possible rational zeros will consist of factors of the constant term, in our case -1, over factors of the leading coefficient, +4. So I'm going to go ahead and say just 1 and 4. When we set these up, we're going to make them both positive and negative, our possibilities for each and every one of these. So 1, I'm just going to list 1 as a factor. 4 can be factored as either 1 and 4 or 2 times 2, but I don't really need 2 copies of 2 as I'm listing this out. Next, let's go ahead and set these up as rational numbers or fractions. The order matters here. So let's be clear on that. We can do 1 over 1, which is the same thing as 1. We can do 1 over 2. We could do 1 over 4, but could we do 4 over 1? No, we can't do 4 over 1 because that's the wrong order. Numerator and denominator got inverted there. So make sure the order matters on these. All right, next, what we're going to do is start testing these and figure out which one is actually going to be a 0. Now, what I would do first is I would go ahead and test any integer values, right, 1 or -1, before I went on to these fractional numbers. So for our purposes, I'm going to choose -1 first. And if we're testing it, it goes out on the outside, and we're going to use synthetic division. And for synthetic division, remember you just steal the coefficients here. So we have 4x cubed. We're missing an x squared, so I'm going to put 0 as a placeholder. We have -3 comes next, and -1 is our last value. All right, and for synthetic division, what we want to do is remember the process is multiply and then add and repeat this. So first of all, the 4 comes down, and we're going to multiply by that red -1 out in front. So -1 times the value at the bottom, the 4, makes -4. Then we add vertically. 0 plus -4 makes -4. -1, again, we're back to multiplying, times -4 makes +4. Add vertically, -3 plus 4 makes +1. Multiply -1 times +1 makes -1. Now we add vertically, -1 plus -1 is -2. That's not what we're looking for, right? What we're looking for is that last value to be a 0, because that means that the remainder is going to be a 0. Next, let's go ahead and test +1. So it's going to go out in front. We're going to use 4, 0, -3, -1 again. And repeat this process. It goes pretty quickly, right? The 4 comes down, we multiply, 1 times 4, add 0 plus 4, multiply, 1 times 4, add, -3 plus 4 makes 1, and 1 times 1 is 1, add vertically, we get 0 at the end. That's exactly what we're looking for. We want a remainder of 0. So what that means is when we get a remainder of 0, one of our zeros is given by that 1 that we just tested. All right. The other thing we'd like to do is go ahead and think about the factored form of this. All right. Zeros go hand in hand with factors. It's always x minus whatever we find for our 0. All right. Now the rest of this, we can write, the rest of the factored form will be that multiplied by whatever the quotient is. The quotient is going to be given by these as being the coefficients. So what we mean by that is this is going to be a constant. This will be an x to the first, and this will get an x squared next to it. So we can rewrite that as 4x squared plus 4x to the first plus 1. At this point, we're down to a quadratic, a second-degree polynomial. So hopefully we're comfortable factoring that by hand at this point without anything fancy. We could pull out the AC method or other techniques, but this 1 is going to have to go as 1 times 1. And then the 4x squared, I think we're going to have to use 2x and 2x in this case, and go ahead and make these both positive. All right, so we had a 0 of 1 that went with this first factor. To get the zeros that go with these other factors, which happen to be the same, let's go ahead and say 2x plus 1. We want to know, when does that equal 0? So we could simply set it equal to 0 and solve down if we're not that comfortable doing it in our heads. So subtract 1, divide both sides by 2. We're going to get another 0 here at negative 1/2. All right, finally, what I'm going to do is, let's go ahead and list our zeros. We're going to have one at 1 and one at negative 1/2. Our factored form, we can think of that as x minus 1. And then because we have two copies of the same thing, we can say 2x plus 1 squared is probably the nicest, neatest way to write that. All right. Because our exponents here are different, we can maybe talk about the multiplicity. The multiplicity of each 0 is going to be based on the exponent that each one of these factors is raised to. So because the first one's raised to the first power, it has a multiplicity of 1. Because the second factor, that negative 1/2, that 0 came from the factor 2x plus 1 that can be written as raised to the second power, it has a multiplicity of 2. So what does that tell us about the graph? Well, it's going to tell us a little bit about the graph of this polynomial function, that even multiplicities touch, and odd multiplicities cross. All right, so the 1, we're going to consider that an odd number. At this 0 or root or x-intercept, our graph is going to cross. All right, and at negative 1/2, we have an even multiplicity to go along with that. So it is going to touch and come back the same direction that it came from. All right, when it gets to that x-intercept or 0 or root. All right, so I know I went quickly through the factoring from the quadratic down to 2x plus 1 multiplied by 2x plus 1, but I hope this helps you as you're testing values, finding zeros, doing a little bit of extra factoring. We just factored a third-degree polynomial without too much hassle.